Now we're going to talk about isographic maps. So to start off, we need to talk about the concept of a field. A field is just a fancy name for an area where you take measurements. Now those measurements could be anything. It could be temperature, air pressure, elevation, humidity. It doesn't matter because the way that you read an isographic map is the same no matter what you're measuring. Now if we fill up a field with those measurements, we call it an isographic map. Now there are 4 general rules for reading an isographic map. Number 1 is that every point in a field with equal value is connected by a line called an isoline, and isolines never intersect. So going back to this original image, if you look at all the numbers that are the same are connected by a line, and those lines never intersect. The 10s are all connected by an isoline, the 9s are all connected by an isoline, etc., etc. Rule number 2, isographic maps must have an interval, and the interval is the change in value from one isoline to the next. The interval is the same for the whole map. You'll notice on this map we have 700 is marked and 800 is marked, and in between there are 4 lines. Those divisions are going to be the same, so that the line above the 700 would be 720, above that would be 740, above that would be 760, and the one above that would be 780, followed by 800. So the interval on this map would be 20 units. You'll also notice that only the bold index lines have numbers. Rule number 3 is that the closer the isolines are together, the steeper the gradient. Now the gradient is a measurement of how sudden the change in field value is. And there's a formula which is on the first page of your reference table, and that is that the gradient equals the change in field value divided by the distance. The 4th rule for reading isographic maps is that a gradient can be graphed by drawing a profile. And isographic maps are always viewing a field from above, and a profile gives us a side view of what that area would look like. And to make a profile, you take a scrap piece of paper, you put it between those 2 points, and each time the edge of your paper crosses a line, one of those isolines, you're going to mark it with a dot, and then you would label it as to what the value of that isoline is. And then the last step is you're going to use those dots on that scrap of piece of paper, and you're going to bring that piece of paper to a graph paper, and that will allow you to graph the profile of your area. And you can see here that we put that scrap piece of paper at the bottom of the graph, and every time we see one of those points, we go up on the scale to the left, and we're going to put a dot everywhere where we saw that point. And then in the end, we connect those lines, and we get a profile of what that landscape looks like.